light of wavelength 500 nanometer is incident on a metal with work function 2.28 electron volt. De Broglie wavelength of the emitted electron is. So, work function is given. There is a shortcut, directly you can calculate all these things. So, if you want work function phi naught or W naught is 2.28 electron volt. So, I have to find kinetic energy. Maximum kinetic energy is energy of the incident radiation minus work function. Here incident wavelength is given, which is hc by lambda minus phi naught. So, there is a shortcut way to directly find out. This is energy in joules, no? The shortcut way, energy in electron volt can be directly found by 12,420 angstrom divided by lambda. That will give the energy directly in electron volt. So, when doing so, 12,420 angstrom by 5,000 angstrom, because lambda is 500 nanometer, should be written as 5,000 angstrom. That's it. So, angstrom cancels. Energy in electron volt will be see 3 zeros here, 1, 2, 3 zeros, that is 12.42 by 5, which turns out to be the total energy, that is 2.48 electron volt. So, coming back to this, maximum kinetic energy is 2.48 minus 2.28. So, that will be 0.2 electron volt. So, that is maximum kinetic energy. Then de Broglie wavelength associated is h by root of 2m maximum kinetic energy. It is an equation we are familiar with. So, h is 6.62 into 10 to the power minus 34 divided by the mass of the electron, emitted electron we have to think of. So, 9.1 into 10 to the power minus 31 into 0.2 electron volt. So, that must be converted into joules. So, 0.2 into electron charge you have to multiply, which is 1.6 into 10 to the power minus 19 coulomb. So, that you are going to get finally 6.6 into 10 to the power minus 9 divided by 2.4. So, that is nearly 2.8 into 10 to the power minus 9 meter. So, looking at the options, it is less than or equal to, greater than or equal to, less than or greater than. That is what is given. Now, you have to conclude. If the kinetic energy is maximum, wavelength is minimum. So, there might be a possibility that not every time the electron has its maximum kinetic energy. Kinetic energy can be lesser than the maximum kinetic energy in most cases. Then wavelength should be more than this value. So, wavelength greater than or equal to 2.8 into 10 to the power minus 9 meter is the right answer, which is option A.